Welcome to Get Your FRQ On. This question is from the 2002 exam. It is question 4 and it is not calculator active. In the question stem, we are given a graph of a function f consisting of two line segments and a definition of a function g, which is the integral from 0 to x of f of t dt. In part A, we are asked to find values for g of negative 1, g prime of negative 1, and g double prime of negative 1. By definition, g of x is the integral from 0 to x of f of t dt, so g of negative 1 would just be the value of that definite integral from 0 to negative 1 of f of t dt, which if we apply properties of integrals, that would be negative integral from negative 1 to 0 of f of t dt, which turns out to be negative 3/2. Also, g prime of 1, by the fundamental theorem of calculus, would just be f of negative 1. Sorry, g prime of negative 1 would be f of negative 1, which, based on the graph provided, f of negative 1 is 0, so g prime of negative 1 is 0. G double prime of negative 1 would just be f prime at negative 1, which, based on the graph, f prime of negative 1 is equal to 3. So we know that g of negative 1 is negative 3/2, g prime of negative 1 is 0, and g double prime of negative 1 is 3. In part B, we are asked for what values of x on the interval from negative 2 to 2 is our function g increasing, and to provide a sufficient explanation. Since g of x is defined to be the integral from 0 to x of f of t dt, g prime of x is simply f of x. The function g, then, will be increasing whenever g prime of x, which is equal to f of x, is greater than 0. So really we're just looking at the graph of f and trying to determine where f is greater than 0. Well, based on the graph provided of f, g prime equals f of x is greater than 0 whenever x is between negative 1 and 1. For what values of x on the interval from negative 2 to 2 is g concave down, and provide a sufficient explanation. All right, so the graph of g will be concave down whenever the second derivative of g, which is f prime of x, is less than 0. Well, f prime of x will be less than 0 wherever the graph of f is decreasing. Okay, based on the graph of f is decreasing whenever x is between 0 and 2. So g will be concave down whenever x is between 0 and 2. And in part D, we are asked to sketch a graph of g of x on the interval from negative 2 to 2 on the axes provided. Now, before we do this, we should take stock of the information that we already know about g of x. All right, we're trying to graph the function g. We can analyze what we know about the function g to determine specific points that need to be on the graph, as well as specific characteristics that the graph must have. Well, in part A, we determined a handful of bits about the graph of g. We know g of 1 is negative 3/2. Right? We can tell from using calculus that g of negative 2 is the integral from 0 to negative 2 of f of t dt, which is 0. So g of negative 2 is 0. G of 0 is obviously 0, since that's just the integral from 0 to 0. We know from part A that g of 1 is the integral from 0 to 1 of f of t dt, which is 3/2. And we can calculate that g of 2 is the integral from 0 to 2 of f of t dt, which is also 0, based on the graph of f provided. Right? But we also know that g is increasing when x is between negative 1 and 1. That's from part B. And we know that g is concave up at x equals negative 1, shown in part A, because g prime or g double prime is positive. Concave down whenever whenever x is between 0 and 2. We found that out in part C. So if we piece all that information together, graph the 5 points, use the fact that it's increasing over certain intervals and concave down over certain intervals, we should get a graph that looks something like this.